Okay, so if you just joined today, we're going to go over an exercise basically for the entire class. I guess actually a few. So we're going to go over how to make some plots using a table. So you need to download a CSV file. So if you're on our Canvas homepage here, you're going to scroll down to week 8, importing and manipulating data. Click on that. And then you're going to download this file here that says Batter's regular season data. Click on that. This page is going to pop up and then click on download the file right here. And then you should get a download prompt. And you want to save that in a folder that's going to be in the same folder that you make a script file later on. Okay, so I'm going to give you guys a few minutes to do that, and then we're going to get started on today's lecture. And if you want, you can download the slides as well.
Professor, where do we go to download the data?
You got to go to Canvas. So if you're on, let's go to the dashboard actually. Okay, so you're on Canvas, you're at the dashboard, click on our class. It's going to bring you to the home page here. Scroll down, go to week 8, click on that, and then you're going to click on this link right here that says Batter's regular season data up top. You're going to click on that. It'll take you here. And now you want to click where it says download Batter's regular season right here. And then you'll get a pop-up to download it.
Okay, got it. Thank you.
Mm-hmm.
Professor,
Yep.
where do we download to exactly?
Any folder that you're going to be using later on today. It doesn't matter where. You just need to put it in a folder where you're going to write your script later. All right, I guess I'll show you guys a little walkthrough here if you're struggling. So I'm going to click save file, okay. And then I'm going to go to our class, so 205. I'm going to go under my lectures. And I'll actually make a new folder. So I'm going to call this class, what's the date? The 12th. And remember in MATLAB, we need to start a file name with a letter. Okay, so I'm going to save this file, this CSV file, right under here, this folder. So I'll click save. Now I'm going to go to MATLAB. And then I'm going to go under that folder that I just created, which was class underscore 10 underscore 12. And then there's the data that I just saved. And then I'm going to create a new script. So to do that, we're in the top left. And then I'll just write a comment here. Importing data exercises. And then I'm going to save this. So I'll click save as. And then I need to put it in that same folder that I just created. I'll call it class 1012. Okay. You can put the file where your scripts usually save in MATLAB, yeah. You can do that, at least in my opinion, that's not as organized though. I would make your own folder, for this class or something like that. Kind of like what I just did.
Professor, sorry. But so after you click on the data, what do you do next to turn it into a .m file? Or do
Uh,
I just have the data out and then I create a new script?
yeah, exactly. Yeah. So
Okay.
the data, that's its own file here. We can see that on the left. That's a .csv. And then you're going to make your own script. And that's going to be the .m file.
Oh, okay. Okay, thank you.
Mm-hmm. All right. Anyone else having any issues to get the data downloaded? Okay. So hopefully you all got it downloaded now because we're going to get started. If you don't, just put it in the chat. I'll go over it one last time very quickly here, but we have a lot to cover, so we'll do it kind of fast. Okay, so we're on the homepage for Canvas for our class. You scroll down under Schedule and Assignments, click on Week 8. That'll take you to this page, and then you're going to click on Batters Regular Season Data. Click on that, it's going to take you to this page, and then you can download this file right here where it says Download. Click on that, it's going to ask you to save it. Save it wherever you want, it doesn't matter. I would save it personally in a file that's under a class or a folder that you have for this class. And then you're going to go to that folder inside of MATLAB so you can see your directory up top here. So if I was like way out over here, I could go and then I could go to the folder where I just saved that data. And then once I'm in that folder, now I'm going to make a new script, and then I'm going to save my script in that same folder where I have that data that I just downloaded. All right. And the slides of the rep as well if you want that. Okay, so again, today we're going to be going over how to import data into our actual script file, and then how we can manipulate that data, extract some data, and plot it, do stuff like that. So this is going to be very, very relevant for the project. I tried to make a lot of the things that we're talking about today kind of coincide with what you're going to have to do for your project. Okay, so I think starting in 2017 in that version of MATLAB, the function XLS read and CSV read that was deprecated, and to instead using a function that's called read table. There's also read matrix and read cell. Don't need to worry about that today. We're just going to go over read table. So if we use this function read table, that's going to allow us to import an XLS file or a CSV file. So in this case, we have a CSV file, just a comma separated value file. So if I double click on that file here on the left, it's called batters.csv. Then we get this right here. I'm just, hold on, let me make sure that I put the correct file up because I know I titled it batters regular season data. I think I might have renamed it. Let's check. Yeah, looks the same. Okay, so now I kind of lost my train of thought, but we're going to be using read table, and we're going to import that data using read table. We have a CSV file here, and then we can import that into MATLAB. So most likely all of you have a version of MATLAB that's later than 2017, so you should be fine. Okay, so let's start by first clearing the memory. So we're always going to start off a script doing this. I'll make a comment called clear memory. Right, then I'll make another comment to import data. And what we're going to do now is we're going to make a variable. It could be called whatever, but we'll go over that. I guess before we do that, I actually have a few slides here. So let's make this bigger. Okay, so first, before we actually import, let's talk about a table versus an array. So far, we've been using arrays in this class. Specifically, we've been using numeric arrays. So just an array full of numbers. That's all we've been doing so far. So a table that can allow us to use or store a lot of different arrays of different data types. So I can have an array here that's called a string array, which is an array that's containing words. So in this case, we have 4 cities here. And within that same table, I can have another array, in this case, a numeric array, which is going to store temperature data that we have. It's extremely hot in Riverside and Death Valley. So we can have these two different data types here in this table. So I can have a string array and a numeric array, while what we've been doing so far with just an array, you can only have one data type. So this is going to make it convenient for us so we can have those multiple data types and we can access them on the fly within that same table. It can kind of keep us more organized. So if I want to access the temperature inside of Death Valley, I can do that very easily because both of those data points, they're within that same table. So to access this data in a table, we're going to use dot notation. So we'll talk about that, throughout this lecture today. But if I wanted to, let's say, get the temperature in San Diego, I would basically call the table name that I have, and then I would put dot temperature, and then I would put the fourth value for temperature. So again, we're going to go over that, but that's basically how we're going to go about it. Okay, so now we're going to import our data. So we already did this. We have our file or the data that we have, and we're going to put it in the same folder that we have for our MATLAB script. We're going to create a script file if we haven't already, and then we're going to import that data. Okay, so let's do that. Okay, so we have our CSV file over here on the left. It's called batters, and then we're in our script file right now. So let's see what I called this. Okay, so I'm going to call our variable for our table here. I'm going to call it hitters. So hopefully some of you are baseball fans because that's what we're going to be using today, data from the regular season for 2020. So we're going to do hitters equals read table. Again, read table, that's our function to import a file. And then we're going to put in the file name that we have inside of an apostrophe or two apostrophes. So for us, that's called batters.csv. And then we're going to close that out, and I'll put a semicolon at the end to suppress it. Okay, now I'm going to run the file. And then if I go to my workspace here, I see that we have a table. So if I hover over hitters, it says we have a 414 by 31 table. So we have 414 rows and 31 columns. So let's double click on that. And then our workspace pops up. Or sorry, our table is going to pop up in the workspace. So here's what we have. We have quite a lot of stuff here. So we have 31 columns. So we have pitches, player ID, player name, total pitches that they faced in the season. There's so much stuff here. So all of this is, if you don't really care about baseball, which is fine, it's just a lot of stats for baseball for each player. Okay.
Professor?
Yeah.
I'm sorry, I actually came 10 minutes late, but are all of this data just on the files page on your Canvas?
Yeah, you can go on the files page or you can just go on the home page for Canvas. So let me go out of here. So you can either go on the files page or you can go on the home page, which eventually takes us to the file page. But go to week 8, then go click on batters regular season data, and then you're going to download that data right there.
Okay, appreciate it. Thank you.
Okay, so that's our table here that we have. So we have a whole lot of stuff that we're going to be manipulating today. That. Okay. I thought I had another comment. All right. So we're going to be using all of that data. So now we have it imported into MATLAB. Okay, so just like we've been doing so far with numeric arrays, we can do array addressing with the table as well. So for us, let's say that we want to extract player names into an array of its own. So we can do that using dot notation. Now I have a few errors here. I thought I fixed all of them, but I guess I didn't. So you'll see here it says players equals hitters dot last name. If we go on our table, we don't have a column variable called last name, but instead it's player name. So last name now is from a different file that I was working on before, but we're going to go over it right now. So let's say that we want to import or make an array just for all the player names that we have. So let's do that right now. So I'm going to make a section here with 2% signs. And I'll do player names in one array. Okay, so to do this, we're going to make a variable called players. And then we'll set that equal to hitters. So hitters, that's our table. So we're going to be referencing hitters quite a lot throughout today. And then we're going to use dot notation. So I'm going to put dot player underscore name. So using this dot notation here, that's telling MATLAB first look at our table hitters, and then the dot that is now allowing us to specify some column that we want to look at inside of that table. So if I open up the workspace again, we're inside of our table called hitters. I put a dot, and then I put player underscore name, and that's going to access this third column here, where we have this kind of header or column variable that's called player name. So if I run the script now, then we have a cell array here that contains all of the names that we have for the MLB. All right, so all we did there is just extract that column into its own array. Now it's called a cell array because it's containing strings, for all of the names. So usually we've been using numeric arrays. In this case, it's a cell array that's containing strings. All right, any questions so far? Okay. Okay, so now let's say that from this, we want to modify this line to only look at the first 5 values that we have for the player names. Okay, so if we just look at our table, we can see that the first 5 values, they are, let's take this out. We have Jose Ramirez, Carlos Santana, Francisco Lindor, Gavin Biggio, and Max Muncy. Okay, so we want those first 5 values. So we're going to be doing array addressing inside of a table. So we've done array addressing a lot before. So we can do that again here. So we're going to do, I'm just going to modify this line. Players equals hitters dot player name. So that's going to access that entire column. And then in parentheses, I'm going to do 1 to 5. Now if I run this and I double click on players for the workspace, then we see that we have those first 5 names. Okay, and you'll also take note that I just put 1 to 5 and that's it. I didn't put comma 1. I could do that and I could run it again and I have the same output, but this comma 1 here, it's not necessary because we're looking at a vector. So because we're looking at a vector, we only have 1 dimension. So that just means I just need to specify whatever values I want within that vector. So that was something I noticed on our last quiz. I think we had a few vectors in there, and some of you would have done, like in this case, 1 to 5 and then comma 1, which again, it does work, but putting that comma 1 is unnecessary because it's a vector. It says you can't open the file. That's and you put in this line of code here for read table. I don't know at which part you said it couldn't open. So if you aren't able to open it, we got another comment. Okay, so it was different for you on Canvas. Oh yeah, now it is. Yeah, it's the same file, which is kind of weird because I downloaded this in front of you, but yeah, so It's the same file, but the one on Canvas has a different file name. So the one on Canvas is batters_reg_season. So yeah, that doesn't matter. You can just type in batters_reg_season instead of what I have, which is batters.csv. It's the same file though. It's just a different name. Okay, so try that, and if you still can't get it to work, then you're just gonna have to stay after class, and then I can help you out. What program am I using to hold the CSV? It's just inside of MATLAB here. Okay, so we're gonna go on now. Again, if you can't open it, then stay after class. But yeah, you should be able to open it. You know what? Okay, so Nick, you're just saving it inside of the folder where you have your script file. It doesn't matter if you save it in Excel. It's just if it shows Excel, that's because it can open up in Excel. It doesn't matter where it's saved as. It's not saving it to Excel. That's just showing that Excel can open it. Or if it opened up in Excel, that's because you opened the file and you didn't save it. I'm gonna make a poll, see how much of you actually have this in MATLAB. All right, so there's the poll. I want to make sure you guys have it installed or working in MATLAB because this is all we're going to be doing today. Okay, so there's 7 of you at least so far that said that you don't have it installed. All right, so Amro, the screenshot that you gave me, it's not running because you have spaces in your script name. You need to put underscores instead. So delete the spaces that you have and then put an underscore. All right, I'm gonna end the poll. Okay, so I'll show you guys one last time on how to get the data imported. Your screenshot shows that you have spaces. If you look at the top of your screenshot under the editor window, it shows spaces in your script. I'm talking about the script file, not the data. So Amro, your script file is called, I'm gonna put in the chat, importing data class notes script. So that's your script file name. You need to put underscores instead of having those spaces there. Okay, so one last time, let's share the screen. I'll show you guys how to get this inside of MATLAB. Okay, so I'm just gonna make a whole new folder here. We'll do that. All right, so we're on Canvas. We're gonna go to week 8. We're gonna click on batters regular season data. Then we can click download batters regular season data. Gotta save it. So I'm gonna make a whole new folder just so we're very explicit. So class 1012 exercise. Okay, so that's my folder that I'm saving this to. I'm gonna click save. I go to MATLAB now. Now I'm gonna go to that folder where I just saved it. Okay, so I'm in that folder. I can see up top here it shows class _10 _12 exercises. That's what I just made. And here's the file that I have, which is batters _reg _season. I'm gonna make a script, make a comment. Doesn't matter what. Clear the memory, clear CLC. Import data. So I'm gonna call this what we just did, hitters equals read table. So in this case, now I have it called batters _reg _season .csv. Then I'm gonna run it. I need to start it with a letter, and there can't be any spaces in here. So I don't know, I'll just call it baseball. Save, and it ran fine. So here is our table that we have here. Okay, so yeah, now I see a comment that yours downloaded as an Excel sheet. So again, it's a little misleading. It shows that because Excel can open it. It's still a CSV file. So yeah, just like Kevin says, once you put it in your folder in MATLAB, it's going to show up as a .csv here because that's what it is. All right, so hopefully all of you have it in MATLAB now. If you don't, again, stay after class and I'll help you out. Okay, so let's do what we already did here, which is getting the first 5 values for the player names that we have. Again, on my slides, I forgot to change these 2 lines here. It shouldn't show last name, it should show player name. So let's do that. Make a section. I'm going to go over this really quick since we already did it. So players, I'll call it first 5. Well, here I'm going to do F5 _ players for first 5 players equals, so we're going to reference our table, which is called hitters. I'm going to use dot notation. So I'm going to do dot player _ name and then 1 to 5. If I run it, then that runs, and then I can click on it in the workspace here. And we see that we have a cell array called F5 _ players. If I double click on that, then we see the first 5 values here. And again, that's what we had under our table for hitters dot player _ name. We got the first 5 players right here. Okay. So we can view properties of a table. I think I was trying to do this last class, but I think we did get something to show up. But there was some issue I think that we ran into. I forget. But we can look at our table properties by using dot properties. So it's a table name dot properties. So our table name is hitters. So I'm going to go in the command window. And I'll do hitters dot properties. And make sure you have a capital P because capitalization does matter. And I'll press enter. And then we can see all of our properties for the table. So there's not too much right now. Once we start filling stuff in, more stuff would show up. But we see we have our dimension names, it's row and variables. So variables, that's these variable names up top here. So we have pitches, player ID, player name, total pitches, and etc. And variable names here, that's what I just mentioned. So all of these were variable names, player name, player ID. So right below dimension names, we see variable names is a 1x31 cell. So that's just saying that we have one row here and we have 31 columns for our variable names, which is just all of the stuff that you see in the light gray up top. So launch speed, launch angle, spin rate, velocity, effective speed, I'm guessing it says, yep. Whiffs, swings, takes, you get the picture. All right, so that can be a good way to kind of just look at stuff at a glance. Or we could also do hitters. We can specify a specific thing that we want to look at for our table properties. So I'll clear this. So I'll do hitters.properties and then .variable names. Again, we need to make sure that we have the capitalization just like this. I'll press enter. And now it's giving us the name of every column of variable name that we have. So we have pitches, player ID, player name, total pitches, etc. And it shows that we have 31 columns here. And that matches up to what we see in our table. Okay. Okay, so now we're going to sort the table that we have here. And if you're wondering, I just wrote this in the command window because I don't care to have it in the script. Using that properties kind of command, that's just helpful to look at table properties kind of on the fly if we want to check something out really quick. Okay, so we can sort our table by some given parameter. And this is going to change all of the indices that we have in the table as well. So if I open up the table here, off the bat, unintended pun, I don't know what I have this table sorted as by default. I'm not sure from where I downloaded it how they sort it by default. I forget. So what we can do, if we want to sort this by some specific parameter, we can do that. So if I'm here and I want to sort it by batting average here, I could do that. And I could have it go from highest to lowest or from lowest to highest. And because I tell MATLAB that I want to sort this table by this parameter, it can do that and then it can change all of the corresponding indices that we have. So it's not going to just, change all of these values. It's going to change these values and all the corresponding values for each column and row. Okay, so we're going to do that right now. All right, there we go. Close out of that. So what I'm going to do is I'm going to sort the table that we have here by a stat that's called WOBA, or weighted on base average. So if I double click on hitters, we saw our weighted on base average under column 10 right here. Okay, so if we look at this right now, we see that there's no kind of definitive pattern here. We have 0.4 here and then 0.3 and 0.319, so it's not descending or ascending. So we're going to change that. So what I'm going to do, I'll go on a new line here. Actually, I'm going to go up here where I imported the data just to kind of keep it close. So I'm going to do hitters. So I'm basically updating our table here. So that's why I'm typing out hitters once again. So hitters equals sort rows. That's going to allow us to sort all of the rows in our table. Then we're going to put the table that we have. So that's called hitters. And I'm going to put a comma, and then in apostrophes, I'm going to put the variable name that we want to sort by. So in our case, that's going to be WOBA, or weighted on base average. We're going to type that in. And then I'm going to specify descend. So descend, that's going to have that's going to sort by the highest WOBA, or highest weighted on base average, to the lowest. Now if I run this and I double click on hitters, let's check it out. I'll make this full screen. So if we go over and we see WOBA right here, it starts at 0.47 and then it's decreasing in value. And that again, it changed all of the other corresponding rows and columns, or I guess I should just say rows as well. Okay, so remember before our first 5 players that we had, they were different names than we see here. Now they updated where we have our entire table sorted by WOBA. So up top, we see that this player, Juan Soto, of course it's Juan Soto. He has the highest WOBA for all of MLB, or highest weighted on base average. Okay, so now we sorted this entire table by weighted on base average. And again, we can do that for any parameter that we have here. We could do it by slugging percentage, by the amount of hits that someone had, by their average exit velocity here. Basically anything that you see up here, we can sort our table by. All right. Any questions on sorting the table? We'll also change our F5 players variable to, yeah, it's going to change that right now. So if I look at that F5 players, now it shows Juan Soto, Brian Hayes, Freddie Freeman, Marcell Ozuna, DJ LeMahieu. So yeah, everything, since I have this line here now to sort rows, it's going to change that as well. All right, any other questions? Okay, so for your project, you're going to need to know how to sort your table for whatever you're looking for, basically. I should also mention, let's pretend that I sorted our table by WOBA like we have here, and then I made some plots. So I have plot, some stuff, comma, some stuff. So I could make that plot right here, and it would make the plot corresponding to how we have the table sorted here. And then I can go on a whole new line and I could type in hitters, sort rows, hitters, and I could sort it by something else like batting average. And then if I was going to make another plot, so if I made this other plot, I would have both plots corresponding to how I sorted the table. So I would have this first plot here, and that plot would be corresponding to how I sorted the data for WOBA. And then my other plot here, pretend I spelled plot right, it would make that plot corresponding to how I sorted the table right here, which was batting average. So it's doing that like how we want it because MATLAB is going line by line to kind of go through the script. Okay, but for here, for F5 players, that was changed because that was after sort rows. And actually, even if let's put this before we sorted our rows. Let's see what happens here. I think I know, but I won't say until I'm sure. So now if I click on F5 players, okay, so I was actually wrong. So it does show what we first had, which was Jose Ramirez, Carlos Santana, etc. All right, so since I have this before we sort it by WOBA, it's not affected by this sort rows line right here. But if I put it after, like we had it, and then I run it, then our players here, they're updated. Okay, so, you know, I really wanted to get more done today, but that's okay. I want to make sure that we know what we're doing. So we have 3 total exercises that we're going to do for this lecture. We're not going to get to all of it today, obviously, but this is the first one that we have here. So this is the plot that we want to make. It's going to be the top 25 MLB players by weighted on base average, which is how we have our table sorted by right now. So this is a stem plot. think we showed this one time before. All right, so we're going to make this plot. So I want you guys to first work on this on your own. You're going to try to make this show up first. This will be just making a basic plot. So let's make a section here and we'll call this WOBA plot. Top 25. So to make a stem plot, if you forget, we have to type stem and then our data that we have. So in this case, we're only going to have one argument here. It's going to be the WOBA. It's going to be WOBA for the table that we have here. So remember, you have to do dot indexing to access the column for WOBA, or weighted on base average. All right, so I'm going to give you a minute to try to get this plot here. Based off of what we talked about already up here, hint, you got to do something like this line on line 12. $20 more seconds. All right, so let's go over this. So hopefully you were able to do it, but if not, we're going to go over it. So again, this is the plot that we want to have, and this is what we're going to currently have right now. So for our first step here. So I'm going to type in stem, and then I'm going to do hitters dot WOBA. That's the variable name that we have. And then I want the first 25, so I'm going to do 1 to 25. And I can run that, and there we go. Now we have this plot here. So it's a little different than what I have here, so we'll update it. So remember, by default, MATLAB, they use blue lines, and our circles, or our circle data markers, they're going to be hollow, so to say. So to change that, we need to type in our color here. So we have black. So that's given by a K. And then we have to type in apostrophes filled. And filled is going to fill in our circles here. So they're nice filled in black circles. Okay, any questions on this plot so far?
I did the exact same thing you did, but for some reason it says I have an error.
Okay, what's the error say?
It says something about the one of my lines that the arguments must be numeric, data time, and duration, or categorical.
Okay, and that's for the line that you just plotted here. It's, in my case, it's line 15, but what is it for you?
No, that's the thing though. Like I did what you did. I updated here hitters, just sort rows, hitters, woba, descend, and it's saying that that's the error.
So it's in this line here.
Yeah, when I hover over it, says terminate statement with semicolon to suppress. Oh no.
Yeah, that's just a warning note to suppress that line.
Okay, let's see.
All right, Andrew, I'll get to you in a second. Did it work now or no?
No, still not working.
Okay, so I'm guessing you have some error in some other place in your script. So it should show you the line where you have the error. Did you say the error was for sorting the rows? It was on that line?
Yeah. Wait, now it's gone.
So it's working now?
Sort of.
Okay,
Oh,
so Andrew, you
oh.
say that you have a graph, but it doesn't look like mine. So, you know, if you type exactly what I have, it should look like mine. And, yeah. So what's different about our? Okay, you got it. All right. I didn't sort the tables. Okay. Okay, so yeah, if you still have an issue, Osceol, if I said that right, I don't know. But if you still have an issue, then stay after class and then I'll help you out with that.
Uh-huh.
All right, so now we're going to adjust the tick values and the limits. So we want to adjust them to, instead of a plot like we have here, so this is what we have so far, we want to make our plot look like this. So make it full screen. So I'll give you another minute or two to try to adjust the tick values that we have here. So these are our tick values, and then the limits that we have to make our plot look like this. All right, so I'm going to time it. I'll give you like 1 minute. All right, I'm going to give you 1 more minute. All right, 20 seconds. All right, so we're going to go over it now. So it's fine if you didn't get to it. I just want to give you guys a chance to work on it on your own so you can kind of already kind of go through that thought process. Okay, so I'm going to show what we have to do. So, so for our plot that we have right here, we obviously want to make this look a bit different because this is kind of absurd right now. All of this data down here is basically, it's not relevant to us, and we're not having any data markers in this area here. And then we look right here on the very edge, we have one data marker that's on that upper X limit. So we want to change that as well. So it's kind of shifted like we have it here. So it's a little more easy to look at. And then we want to change our tick values to be from 1 to 25 because we have 25 players. Because later on we're going to add their names. And then here we're also changing the tick values a bit to go by 0.01. So we're going from 0.38, which is the lowest value here that we have for our Y range, and then we're going to go all the way up to 0.5. All right, so let's do that. So what we have to do is we're going to first adjust the the X tick. So let's actually, I'm going to get my plot up again. All right, here we go. So we're going to adjust the X tick. So right now we have our ticks going from 0 to 25 and they're in intervals of 5. So I don't want to have that. So I want to do X ticks from 1 to 25. Again, we're doing 1 to 25 because we have 25 players. Now if I run it, then we get our X ticks that's updated and starting right here, going from 1 to 25. Okay, so that's fine, but this still doesn't look good because we have this last data point right on the edge of our X limit. So let's change our X limits, so we can make that look a bit better. So we type xlim, and then in brackets, we're going to type the minimum limit, so 0, and then the maximum limit. In this case, we're going to put 26. So let's run that, and then I'll explain why. So in this case, we have 0, that's our minimum limit, and then 26, that's our max limit. So that's basically giving us some padding for this plot. So our first data point isn't, on the edge here, and our last data point isn't on the edge over there. All right, so that just makes our plot look a bit nicer. And now we have to adjust the y-axis stuff. So let's do y ticks. And for this, I'm doing 0.38 to 0.5. So why am I choosing 0.38? I know that if I hover over this plot or this data point, it's going to show 0.0389. So that's corresponding to this player's weighted on base average. So right around that value, that's where I want to have the bottom of my plot, or the bottom of my y-axis. So if I had a ton of data points and I couldn't just hover over that data point easily, what I would do is I would go to my command window and I would type in headers.woba, and then I would specify 25, so that 25th value for woba as we have our table currently sorted. Press enter, and then I see 0.389. All right, so I'm going to type in y ticks, and then we're going to do 0.38 because that's the bottom limit that we want here. Now we're not doing limits here, but that's the first y tick that I want. So 0.38. And I'm going to go in an interval of 0.01. And then I'm going to have our last tick be 0.5. I'll run that. So we have our ticks here. It currently looks really weird. That's because we haven't adjusted our y limit yet. So we'll do that. Type in ylim. So I want to start at 0.38, like we just said. And then I want to have the maximum y value be 0.5. And now if I run it, then we get our much better looking plot here. In fact, I could actually change our y limit to be a little different. I could do 0.48, and let's change our y tick value as well to 0.48. Now let's run it, and then we have this. This is how I probably should have done it from the beginning. And so this is our plot right now. You have different data. You shouldn't have different data. I just downloaded the file again in front of all of you. So make sure that you sorted the rows correctly. That might be why. Everyone else have what I have? Okay. Yeah, you probably just sorted the rows a little wrong. Okay, so now we want to add the names for the plot. So if I go back here, make this full screen. So we want to have all of the names because obviously we want to know who we're looking at. And then we're going to add a y-axis label here. I have the wrong name here. I have OPP, which is on base percentage. It's similar to WOBA, but whatever. I was using some other data from when I made this slide. So we're going to change that. And then we're going to add a title and then a grid as well. Okay, So let's do that right now. All right, so first thing we're going to do, we're going to add our Y label that we have. Let's actually go back. I want to make sure. Yeah, okay. So you'll see in my slide here, I have this line here that's called YTick format. And then in apostrophes, I have %, then 0.2f. So why do I have that? If I go back to this slide here, you see this is my YTicks. I have 0.4 and I have 0.5 here. So we have 1 digit after the decimal. Sorry. And everything else has 2 digits after the decimal. So I want to be consistent with what I have. So here I have this 0.4 value. I want to change that to be 0.40. Okay, so that'll be the first thing that we adjust. So I'm going to go right here and I'm going to do YTick format. And then I'm going to put a %, and then 0.2. So that 0.2, that means 2 digits after the decimal. And then F, that just means our format for, our decimals here. Now I'm going to run it. And then you see that this updated to 0.40. If I did 0.3, then we have 3 digits after the decimal point. But I want 0.2. Okay. And then we have Y label. So we need to call this the correct stat. So that's WOBA, weighted on base percentage or average. And then we'll add in our title. Top 25 MLB players by weighted on base average. And then I'll put WOBA. Okay, now we need to add our tick labels here. So right now we just have digits. We want to know the players that we have. So I'm going to do X tick labels. And you see I'm grouping everything here by, I'll actually do it like this. We have all of our kind of X-axis stuff, our Y-axis stuff, and then the labeling that we have for the plot. All right, so X tick labels, I'm going to do hitters dot player name and then 1 to 25. So what we're doing here is just array addressing, right? So we already sorted our table by weighted on base average. Now I'm going to show the player names for these top 25 players here. So all I have to do is hitters.player name so we can access that column. And then we want the first 25 player names right there. Then I can run it. And here is our lovely plot. Not very useful unless I make it really big. I can kind of see the names, but yeah, it looks pretty bad, right? So we gotta change that. So we're gonna do X tick angle and 45, and that's gonna change our tick angle here to 45 degrees. Now we run it, then we get our plot right here. And that looks good now. So now we can see that, of course, our first player is Juan Soto. He has the highest weighted on-base average. And we have Cabrera Hayes, then Freddie Freeman, Marcell Ozuna, etc. We go down the list. Mike Trout over here, lonely at number 17. How sad. All right, so there we go. So if you see in this this plot here, it almost looks like Mike Yastrzemski right here, that his WOBA is higher than Mike Trout, even though he's after. This is just a rendering kind of issue with on Linux. It doesn't render as well for the preview here. If I save the file, it looks better, but they both have the same value, which is 0.4, at least how it's rounded to. Okay, any questions on this plot? Oh yeah, I need to add a grid as well. So type in grid. There's the grid. All right, no questions? So as I keep saying, this will be very relevant for the project. Imagine that instead of names here, we had like counties or countries. So you're going to be accessing those names from your table that you have. And then you're going to make a plot that looks, honestly, something like this will be kind of expected. You might have some bar chart for the amount of cases, by country, something like that. All right, so now we're going to go on the second exercise here, which is extracting, because I'm an Angels fan. We're going to extract data that's related to Angel players. Okay, so I'm going to close out of that plot, and I'm going to comment out everything that I have here for the plot, just so I don't kind of have that interfering with us. All right. So if I look at our table here, we see that we have the player name. Oops. All right, so we have the player names, but that's all we have. It just shows the player name, and it doesn't show, like in another column right next to it, it doesn't show the team that they're on. So honestly, that's kind of a little downer for this plot, because if it had that, it could make stuff a lot easier for us. There might be a way on the website where I got this data, which is Baseball Savant, where you can maybe do that. I couldn't find a way, but so there's no built-in tag here that can have our player name and then their corresponding team. So right now we want to make a plot, and we want to look at all of the relevant data for our Angels players. So because we don't have that tag for which team a player is on, we have to make a string array ourselves. I'm going to make another section, and we'll call this Angels players. All right. So what we have to do again, we have to make a string array, because I want to look at the data for all of these players here. So I'm going to call this angels underscore n, just for angels names. And, I didn't check if I missed anyone. I just was naming people off the top of my head. So to make this string array, we have to put all of our names here inside of curly braces. So we're going to do a left curly bracket. And then for each name, we have to surround that with an apostrophe. So we'll do Mike Trout. Obviously, he's got to be the first one. Anthony Rendon. And then David Fletcher. Maybe Fletcher should have been first. Great guy. Shohei Ohtani. Justin Upton. So if you don't feel like typing all these out, then, you don't have to. So make sure you type out, I don't know, like 5. Joe Adele. What a sad season. Taylor Ward. Just got to put a comma. Jared Walsh. Albert Pujols. Maybe I should have put him before. The disrespect. And Luis Rengifo. Alright, and then we have to close that out with another curly bracket here, and then we're going to suppress the output. Alright, there we go. If I run our code, then in the workspace here we have a cell array which is containing strings. So if I click on it, we have, in this case, it's a row vector. It doesn't matter. So we have Mike Trout, Anthony Rendon, all of the names that I just put in there. So we have 10 players. Okay, so we have all of those now. Again, if you didn't type all of them out, that's fine. Just make sure you have, a few of them right here, like these first 4. Or you can add in Justin Upton as well. Okay, so we have all of our names here, but we want to access the data for all of these names. So how are we going to do that? We have to find their corresponding row. If I double click on hitters, I don't want to have to just scroll through here to find each of the row is for the corresponding player. Now I can see Mike Trout pretty easily because it's currently sorted by weighted on base average. But it would kind of suck to just keep going through here manually to try to find all of the other players that I want to look at, right? Imagine we had a data set that was thousands of rows. There's no way you would do that manually. So we have our string array, and now I want to find those corresponding rows or indices. So I'm going to make a new variable here, and I'm going to call it angels underscore ind, where ind that just means index. And then we're going to use a kind of a funky command here. So it might look a little weird first. So what I'm first going to do is I'm going to type is member, and then hitters, get out of here, hitters dot player name, and then comma angels underscore n. If I run this now, then you see we have a table, or not a table, an array here that's a 41 by 1 or 414 by 1 logical array. So what this function here is doing, this function is member, it's telling MATLAB to look at the column hitters.playerName and compare that to the names here that are inside of the string array, which is called angels underscore n. So we're going inside of our table, which is called hitters, and MATLAB is saying if there is a name in angels underscore n that matches the name for player underscore name in our table, then put a 1. So a 1 for like a logical expression, that means true, and a 0 is going to mean false. So if I double click on that array that we just made, which is angels underscore index, you see here we have a lot of zeros. Again, that means false. And 17, we see a 1. So remember, back when I was looking at this table here for hitters, player name number 17, that was Mike Trout. That's one of the names that we put in our string array here for the angel players. So we know that's working. Then we see another one on row 23. Row 23, yep, that's Rendon. We see right there, Anthony Rendon. All right, so it's going to keep doing that. It's going to keep matching these names to the table. So again, a 1, that's going to mean true, and a 0 means false. All right, so first I want to make sure that you guys understand that. If you don't, I can repeat it. Just tell me in the chat if that makes sense or not. Okay, good, because that'll be another big thing for the project. Okay, so before is member, I'm going to type find. So if I type in find and then a left parentheses, now I got to close it out at the end as well. Okay, so all I did is I added find, left parentheses here, and then a right parentheses at the end. Now if I run this, we see our workspace had changed now to a 10 by 1 double. If I double click on that, then now it has all these numbers here, and they correspond to the row for the table here for hitter. So we have 17, 23, 33, etc. So 17, remember that was Mike Trout, so we see that. And then there's 23, Anthony Rendon. And we have 33. Is that going to be Walsh? Yeah, that's Walsh. So we have Jared Walsh. And let's do one more just to make sure. Row 100. Row 100, David Fletcher. All right, so now because I used find, that function that returns an index the corresponding index for our argument here, which in this case was angel player names. Okay, so to kind of break it down one last time, is member that returns a logical kind of result, a 1 or a 0. if our argument here, angel names, matches some name inside of the table for player names. And then the function find, that returns the corresponding index. So I don't really care for a 1 or 0. I mean, that's useful, but I want to know which row each player name corresponds to in our table. So that's why we use this function right here, find. Okay, any questions on that? Okay, so let's see if, what's the next slide? Okay, so we'll do one more thing here, and then we gotta end it for today. Okay, so I have all of the indices for angel players now. Now again, I wanna just look at data for angel players. So what I can do is make a table, just so it's kind of easier to look at all the data. I can make a table just for angel players. So I have all their indices for the table that we currently have. And now I can use those indices to make a table of our own for angel players. So what I'll do is angels, maybe I'll do _t for table. Then I'll set that equal to hitters, so that's the table that we currently have. And then I'll do, in parentheses, I'm doing array addressing for our table now. I'm going to put angels _ind for index, and then a comma, and then a colon. And there we go. So this line here, it's saying that we're going to make a table, and we're going to take all of the rows for our indices that we just made here for angels _indices. And so we're going to take all of those rows from the table hitters and all of the corresponding columns. So let's take row 17, for example. We're telling MATLAB that I want to take row 17 and I want to take all of the columns for row 17. So all of that data for Mike Trout. Likewise, we're doing that for row 23 for Rendon. We're on that row and we want to take all of that data for him. So all of those columns. And then it's going to be the same for all of the other angel players that we have. So now if I press run, and if I look in the workspace, we see angels _t. If I hover over it, we have a 10 by 31 table. If I double click on that, and I open it up, make it full screen, then we have our table here that's just made up of angel players. So it's just like our table that we first had, which is called hitters, but now it's a table just for angel players. Okay, and then from this, we're going to, next time, we're going to make a plot. I'm going to go through it fast just so I don't spoil the code yet. But this is the plot that we're going to make. So it's going to be a plot for slugging percentage versus launch angle. And then we're going to add in these kind of automated text labels. So we don't have to type in all of these names ourselves and then drag it to the corresponding data point. MATLAB will be able to put in all of these labels automatically based on some code that we have. Okay, so 11:15 now, so that's all we have for today. Maybe it was a lot, I'm not sure, but again, these set of slides, of course, everything that we covered in the class so far is just going to be very relevant for the project, but especially these slides here, they're going to be very, very, very relevant for your project. All right, so that's it. So I'll see you guys on Wednesday. If you have any questions, then stick around and feel free to ask.
Yeah, Professor, just real quick, going back to the previous example of the graph, of the stem graph.